Let's talk about IP addressing. IP addressing, that's one of those topics that can be one of the more challenging topics for people just getting into networking, perhaps because it does get a bit mathematical. We need to have an understanding of binary numbering and how binary numbering relates to subnet masks and IP addresses, and we're going to get into all that, and we're going to spread this over 4 videos. In this video, the first video, we're going to be talking about binary numbering. We're going to review how to convert a binary number, in other words, a number composed of ones and zeros, into a decimal number and vice versa. And then we're going to shift our focus to IPv4. IP version 4, that's a 32-bit IP address, and we're going to take a look at some basic subnetting principles. You see, of those 32 bits that make up an IP version 4 address, some of those bits represent the network on which a device resides. The remaining bits represent the device itself or the host itself on that network. And we're going to see how we can do some design and say, if I need this many hosts, what sort of subnet mask do I need? Or if I need to support this many subnets, this is the subnet mask that I need. We'll talk about that in our next video. And then we're going to dive even deeper and get into some more advanced subnetting. An advanced subnetting scenario might be something like taking a look at a topology and saying, we've got these different hosts with different IP addresses. We want to make sure that all of the hosts hanging off of one router interface that should be part of the same subnet, we want to make sure they really are part of the same subnet. Can we look at a couple of IP addresses given a subnet mask and know if they belong to the same subnet or not? We'll talk about that in our third video in this series. And finally, we're going to shift away from IP version 4 and give you an introduction into what's coming, IP version 6. Instead of having a 32-bit address, IP version 6 gives us a 128-bit address. In our lifetime, we will never run out of IP version 6 addresses. But in this first video, let's focus on binary numbering. And we're going to focus on binary numbering from the perspective of IPv4 addressing. Remember that I said that an IP version 4 address had 32 bits. As we're going to see in our next video, we're going to take those 32 bits and break them up into 4 different 8-bit chunks, 4 different octets they're called. This is what an octet looks like. We have 8 binary numbering positions. And the way we take a binary number and represent that binary number, again, a binary number is a series of ones and zeros, the way we represent that binary number as a decimal number is we start out with a table like this. If you're on an exam, you might want to write this out on that scratch paper that they give you, or that dry erase marker board that they give you. And notice how we construct this table. Starting from the right, we have 1, and then it doubles, we have 2, and then it doubles, we have 4, and then 8, 16, 32, 64, 128, for a total of 8 columns. Where do these numbers come from? These are actually powers of 2. Specifically, on the right-hand side, a 2 raised to the 0 power is a 1. In fact, just about any number raised to the power of 0 is a 1. And then 2 raised to the first power is a 2, and 2 raised to the second power, or 2 squared, is a 4, 2 cubed is 8, 2 to the fourth is 16, and so on and so on. So it's the powers of 2 starting with 2 to the 0, which is a 1. Once we have this column, we're going to be able to very easily take a look at an 8-bit binary number and convert it into a decimal number. Let me give you an example. Here we have a binary number of 100101110, and what we want to do is to convert that into a decimal number. And because we took the time to make this table, it's very simple. We're just going to add up all the column headings that have a 1 under them. For example, 128, that's got a 1 under it. 16 has a 1, 4, 2, they have 1s. We just add up all those column headings that have a 1. In other words, 128 plus 16 plus 4 plus 2, if we add all that up, that gives us 150. 150 is the decimal equivalent of the binary number 100101110. It gets a little bit more complex when we go in the other direction, however. Let's see if we can now take a decimal number and convert it to binary. Let's say that we're given a decimal number of 167, and our task is to calculate the corresponding binary number. We can still leverage this 8-column table that we talked about, and here's the logic that we're going to go through. We take a look at our decimal number of 167, and we start at the left-hand side of this table, and we ask this question: is 167 equal to or greater than 128? the leftmost column, in other words? And the answer is yes, it is. 167 is greater than or equal to a 128. And since it is, here's what we do. We're going to place a 1 in the 128 column, and then we have to calculate what's left over. In other words, we're going to subtract this 128 from our number of 167. That gives us a 39. Now, when we go to the next column, when we go to the 64 column, we're asking a different question. We're saying, is 39 equal to or greater than 64? 39 is the remainder after we subtracted 128 from 167. Is 39 equal to or greater than 64? In this case, no, it's not. If it's not, then we're going to place a 0 in the 64 column, and then we're going to move along. We're going to go over to the 32 column and ask, is 39 greater than or equal to 32? Yes, it is. And remember what we did with the 128 column? Because 39 is equal to or greater than 32, we're going to place a 1 in the 32 column, and we need to calculate a remainder now. What's left after we take away 32? What is 39 minus 32? It's 7. When we go to the next column, the 16 column, we're now going to be asking, is 7 equal to or greater than 16? Obviously, no, it's not. What do we do if it's not? We place a 0 in that column. And after we place a 0 in that column, we move over to the 8 column and we say, is 7 equal to or greater than 8? Still, no, it's not. What do we do? Well, we're going to place a 0 in the 8 column in this case, and we're going to move along to column 4. Is 7 equal to or greater than 4? In this case, yes, it is. Remember what we do? We're going to subtract 4 from 7, and we're going to place a 1 in that 4 column, and when we subtract 4 from 7, that's going to give us a remainder of 3. Let's move over to the 2 column. Is 3 equal to or greater than a 2? Yes, it is. Based on that, we're going to place a 1 in this 2 column, and we're going to see what's left over. We're going to subtract 2 from 3, giving us a remainder of 1, and finally we move to the 1 column and we ask, is 1 equal to or greater than 1? Yes, obviously 1 is equal to 1, so we're going to place a 1 in the 1 column, and we shouldn't have anything left over now. We're going to say, let's subtract 1 from 1. That's going to give us a remainder of 0. And by the way, it just happened in this case that our remainder was a 0 on the very last column. It's possible that we might have had a 0 remainder back in column 32 or 16. If that's the case, we don't have to evaluate all the other columns. They would just all be zeros. And now that we've gone through a couple of demonstrations, and the great thing about this being on video is you can go back and review it if you didn't follow every single step, but I want to give you an opportunity to do some calculations of your own. First, let's start out with a basic binary to decimal conversion. I'll give you this binary number of 011011011. Your task is to convert this into a decimal number. Here's what I'd like you to do right now. Pause the video and work this out on some scratch paper. Give you just a couple of seconds to do that. Go ahead and pause the video, and we'll see you back in a few seconds. All right, welcome back. Did you take time to stop and do this? If you did, let's check your answers. Remember how we convert binary to decimal? We put the binary numbers in this 8-column format, and we simply add up all the column headings that have a 1 under them. In this case, it's going to be 64 plus 32 plus 8 plus 2 plus 1. That's going to give us a decimal equivalent of 107. All right, let's get a bit more challenging now. Let me give you a decimal number and ask you to calculate the corresponding binary number. Here's a decimal number of 49. Again, pause the video and see if you can convert 49 into its binary equivalent. We'll see you back in just a few. Welcome back. Let's see if you calculated the correct binary equivalent of 49. Let's go through the questions we went through before. We start out by saying, is 49 greater than or equal to 128? No, it's not, which means we're going to put a 0 in the 128 column. Let's move over to the 64 column and say, is 49 greater than or equal to 64? No, it's not. A 0 goes in the 64 column. Is 49 greater than or equal to 32? Yes, it is. This means we're going to put a 1 in the 32 column, calculate the remainder. We're subtracting 32 from 49. That's going to give us a remainder of 17, which means we're going to ask, is 17 greater than or equal to 16? Yes, it is. We put a 1 in the 16 column. We see what's left. We subtract that 16 from 17, giving us a remainder of 1. And we say, is 1 greater than or equal to 8? No, it's not. We put a 0 in the 8 column. 1 is also not greater than or equal to 4. So a 0 goes in the 4 column. Is 1 greater than or equal to a 2? No. Let's put a 0 in the 2 column. And finally, is 1 greater than or equal to 1? Yes. Let's put a 1 in the 1 column. 1 minus 1 is 0. There is nothing left over. This gives us our binary equivalent to the decimal number 49, and that binary equivalent is 00110001. If you want some more practice, here's what you can do. You can use a binary calculator. And you can find a binary calculator for just about any operating system. I happen to be running Microsoft Windows 7, and I'm running the calculator program, and I'm going to switch to View Programmer to allow me to do my binary to decimal conversions. If you're running Microsoft Windows XP, you would select the scientific calculator, but with Microsoft Windows 7, it's the programmer option. And we could take our decimal number like we were playing with earlier if we want to do some practice and check our work. Earlier, we had a decimal number of 49. I could key in 49 and notice bin for binary. I can click that little radio button and it's going to convert it to binary for me. 110001. And you might look at that and think, oh, hold on, that doesn't look like what we just did. We calculated a number of 00110001. That's okay. This is still a correct answer. It's just that the calculator is not going to show any leading zeros. Just like when you write the number 12. You don't write 00012, you just write 12. Same thing here. We were focused on 8 binary bits because 8 binary bits makes up an octet that we have in an IPv4 address. So no worries if we get less than 8 bits in our result. The calculator is simply leaving off the leading zeros. If you want to go in the opposite direction, if you want to create a binary number and see if you can convert it into a decimal number, let's try that. Let's say that we had a binary number of 100101110. This is the number that we showed you at the beginning of this video that converted into a 150. And if we want to convert this binary number to a decimal number, we just click on DEC for decimal, and it shows us that the decimal equivalent is a 150. Again, use a calculator for more practice on your own. Make up your own numbers and double check it with your binary calculator. Well, I certainly hope you've enjoyed this first video as we start to wade into the waters of IP addressing. And we've focused today on a critical skill, and that is binary numbering. We'll see you back for our next video dealing with basic subnetting.